Right, so we've got a few questions to work through here. The first one's on a bit of polynomial division. Now, I'm not sure, but I heard a rumour that some classes were told we don't need to do this in the exam. I'm going to show you anyway because it's an important skill, but you're probably better off checking with kids in the other classes and just confirm whether or not they were told anything like that. Now, remember, I'm going to do C here. When we have a power that's missing, so we go from x to the power of 4 to x squared, just put in the 0x cubed. It just helps line everything up and make sure everything works beautifully. Take one. So we start by just looking at the first term. Oh, what am I missing there? My plus 1 never showed up. There you go. X squared, how many times does it go into x to the power of 4? Well, it goes in x squared times. Now you multiply the x squared by each of the terms in front. So x squared by x squared is, of course, x to the power of 4. That's why we chose it. X squared by negative x gives me negative x cubed, and x squared by 1 gives me x squared. Just like regular long division, we now subtract each of those terms. The x to the 4's cancel, of course. 0 minus negative 1 becomes positive 1, so that's positive x cubed. 3x squared, take away x squared, is 2x squared. And because this is a 3-term divisor, we need to bring down this other value here of x. And we go again. How many times does x squared go into x cubed? X times, of course. Do the multiplication. X cubed, take x squared plus x. Subtraction. X cubes cancel. 2x squared minus negative becomes plus another x squared. So that's 3x squared. And x minus x is 0, so plus 0x. And we bring down the negative 1. This will be the last time because the x squared is the same power, so it goes in 3 times. Let's put 3 in there. 3x squared minus 3x plus 3. Do our subtraction. And we're going to have 3x minus 4 is the remainder. So they ask us to write it in this form, p of x equals. So how do I do that? Well, p of x was x to the 4 plus 3x squared plus x minus 1 divided by x squared take x plus 1 is equal to x squared plus x plus 3 multiplied by x squared take x plus 1. And then this is my remainder plus 3x take 4. Oh, now they don't even need you to write it as a fraction. That's all they want you to do. So they just want you to write plus 3x minus 4. And we're done. All right. I hope that helps. Cheers. Now I've seen why this has been said here. I don't understand how to rearrange our answer into the formula that's given. That's actually what they've asked for, the divisor, the quotient, and the remainder. That's exactly what we wanted to have. But the way they've written their answer in the book is the way I would actually write it. If we take this division, what is the solution? Well, the solution, when I do the first one divided by the second one, is, so what I've written up there actually is that, isn't it? The polynomial divided by, the polynomial is equal to that expression. That's how they want you to write it. When you do it as the division, so these will be equivalent statements when I go x to the 4 plus 3x squared plus x minus 1. When I actually do the division and divide it by x squared, take x plus 1, then what I'm left with is the x squared plus x plus 3. So that's what we got, isn't it? And the remainder you write as a fraction, plus 3x take 4 over what the divisor was, x squared take x plus 1. And so you can see to obtain that expression, all I do is divide each side by what I was dividing by. So they're equivalent expressions. They've actually asked you for this version here. If I had it over the divided by before because I was doing the division. But they've asked you to write it in that form, but in the answers they've given it in this form here. So that's probably where the confusion is. But that should help you anyway. All right, let's move on to something else. P of x equals x take 2, x squared plus 2x plus 3 plus 7 outside the bracket. What is the quotient and remainder when px is divided by x minus 2? Well, you can see when p of x is divided by x minus 2, I got my answer of the quotient equals x plus 4. Not sure what went wrong. Well, this is, you can see this is in the form that they just talked about before. We've got d of x, then q of x. D of x, so the divisor, the quotient, what you get after you do division, plus the remainder at the end. So just like the one we were just talking about. So when this is divided by x minus 2, well, that's a factor there, so that just disappears, doesn't it? So I'd be left with this expression here, x squared plus 2x plus 3, and the remainder would be 7 over x take 2, the thing I'm dividing by. See, if I divide that expression by x take 2, we'll just cancel in the first term, and I'll be left with plus 7 over x minus 2. And that's all there is to that one. So that one wasn't too bad at all, was it? All right, let's keep going. So we scroll down, and what do we got? Find the zeros of question 1f. I'm not sure how to find the zeros in this type of equation. I tried completing the square, but it did not work. Oh, it would have worked beautifully. This is a little bit tricky because we've got the power of 4, but remember, z to the power of 4, I could think of, if I just said let x equal z squared, what would I have then? I would have x squared plus 4x minus 5. And that would be able to be factorized pretty easily, wouldn't it? This would be x plus 5, x minus 1, which of course we can now replace the z squared back in. And get z squared plus 5. In our real number system, that's not going to factorize, is it? So that's okay. And here we've got z squared minus 1. Of course, that's our favourite rule in maths, so we get a little bit excited. Z squared plus 5 isn't going to factor, but then I've got z plus 1, z minus 1. So the zeros that we can find, the real zeros, and remember in this exercise, those of you doing Math C will be aware that you can find the imaginary ones as well, but the real zeros for this one are just z equals 1 and negative 1. And there we have it. All right, let's keep going. All right, so on to our next one here. Find the roots of 5x squared equals 3x plus 2. So we just get everything on one side. Well, remember to keep your coefficient of the x squared positive. That makes your life a lot easier. So I've subtracted 3x and subtracted 2 from each side. Now when I want to factorise this, I've got to get numbers that multiply to negative 10. Remember a times c, and then add to negative 3. So that's going to be negative 5 times 2 and negative 5 plus 2. When I do my factorising, I'm going to go with this Australian method. Why not? Keep the 5x in both brackets to start off with. And remember, it was negative 5 times 2 gave me negative 10, and negative 5 plus 2 gave me the negative 3 I needed. So that's correct. But I've cheated. I've got a 5 in each bracket. Put it over 5. I know that it's going to factor out of one of these expressions, and you can see it factors out of that first one, so it's going to cancel. So now I've got x minus 1 times 5x plus 2 equals 0. Null factor law, x minus 1 must equal 0, so x equals 1. Or 5x plus 2 equals 0, so x is going to equal negative 2 divided by 5. And there you have it. So that one's pretty good. I'm not sure what the problem was. Remember, you can check what answers you're going to need by just putting that in on your calculator. It'll tell you what you should be getting, so you should be able to figure your way there. Look at this, we've got some working out for this one, which is good to see. Find the equation of the real cubic polynomial, which cuts blah, blah, and blah. Attempted at these questions. Yes, these are fun. All right, good to see we've got some attempts here. So 5. Yep, x-intercepts at a half and negative 3. So we've got x minus a half and x plus 3. That's correct. I think what's going to happen here is when you do this, oh no, look, you factored out a half there. So that you would hope that would be correct. I don't know, it looks like you're working out all right there. What we're missing though is you've got another x term missing from here, because this says it is a real cubic polynomial, and what we have there is not a cubic, but then suddenly it becomes a cubic down here. Maybe that's just comparing it to what the answer should be. Let's have a look at how I do that, and hopefully that'll make it clear and we'll be all good. Here we go for A. All right, find the equation of a real polynomial which cuts the axis there and cuts the y-axis at that and passes through. Do a sketch for these. Give yourself a head start. And in fact, often getting a sketch might be what you're given in the question anyway, but That's okay. So here we go. We've got our y coordinates and our x coordinates. So it's cutting the axis at a half and -3. So let's put -3 about there. There's a half. It cuts the y-axis at 30. Wow. All the way up there. And passes through 1, -20. So when I'm at 1, I'm all the way down here at -20. 1, -20. Now, if we tried to draw in the graph for this, it's interesting because we could have it looking like that. Well, except that I didn't go all the way down through -20 there, did I? But I could also have had it, how would I have had it? I could have had it starting, if you just have a look in the red pen here, it could have started and come down, up, and then just go down like that. So we can't be too sure, but we can work it out just by doing the algebra, and only one of those sets of values is actually going to work. I wonder whether it'll be the red or the blue one. Let's find out. So here we go. Exactly the right way to start. Y equals a, some sort of factor, x minus, let's call it m for the intercept. I don't know why m. Why not is a good enough reason. We don't know one of the factors, do we? I do know that x minus -3, which becomes x plus 3, is a factor. And indeed, we have that over there. And x minus a half. Now, I'm happy for you to do x minus a half. Yes, the book will write it as 2x minus 1, and we can worry about that later. But that's perfectly acceptable. You just have a different value for a. It doesn't matter. You can put that in at the end, fix it all up nicely. That's not an issue. So here we've got an interesting thing, though. I've got two variables I need to figure out. But what else do I have? I've got two other points. When x equals 1, the total value is -20. So if I substitute that in first, I'm going to have -20 equals a, 1 minus m, 1 plus 3 is 4, and 1 minus a half is a half. So now I've got -20 is going to equal 4 by half is 2, so 2a, 1 minus m, or -10 equals a times 1 minus m. And I'm just going to leave that there for the moment because I had another point that I could use as well, didn't I? Running out of room here a little bit, but I know when x equals 0, the whole thing equaled 30. So let's use that. So when y equals 30, I'm going to have a, 0 minus m will be -m, multiplied by 3, multiplied by -1/2. So I think that's going to give me 20 equals a times m. Now let's just see, what did I do there? -3 over 2, so I'm going to multiply, I'll multiply by -2 first to get rid of that. So it's going to be -60 equals a times -3am, dividing by -3, -60 divided by -3 gives me 20. Okay, that works. So 20 equals a times m. Now I've got two expressions where I can solve happily for one. Well, there's lots of ways you can do it. Let's just do substitution. I would probably like to do this one divided by the other one and have the a's cancel because that's a lot of fun. You can try that yourselves and that will give you the same answer, but let's just do a bit of substitution because I know that most of us prefer that. So I'm just going to get a equals 20 over m, and I'm going to substitute that into the other equation that I had. So now I've got -10 equals 20 over m times 1 minus m. Multiplying through by m, so multiplying each side by m, I'm just going to have -10m equals 20, 1 minus m. Now it's becoming pretty easy, isn't it? 20 by 1 is 20, 20 by -m is -20m. I add 20m to each side, I've got 10m equals 20, m equals 2. We can go back into the original one up here and therefore get a equals 20 divided by 2, which is 10. We've got the two values we need. We can now write our answer. For the equation is going to be a is 10, x minus 2, x plus 3, x take a half. And as I said, that doesn't look quite as nice with the x take a half there. So what we do is we just take a factor of 2 out of the 10 and multiply it into that bracket. So I'm going to have 5, x take 2, x plus 3, 2x take 1. Now, before some of you ask, why didn't I multiply it into every bracket? Remember, this is all one term. These are all being multiplied together. If I say 3 times 2 times 4, you don't go 3 times 2, 3 times 4, and then multiply those two things together, do you? No. So I can just multiply it into whichever bracket I like. I put it into that one. They're both correct. And there you have it. All right, a little bit of a marathon video there, but that should be a good start for us. Cheers. Good luck with your study, guys. Bye.